we know that a single perceptron is essentially a linear classifier. So what can we do with a network of perceptrons? So let's once again take a look at a single perceptron, which we've discussed before. This particular perceptron here, and just as an example, has -2, -2, and 3 as the weights and bias. And we showed that this perceptron acts like a linear classifier, where the boundary, the decision boundary, is this straight line right here, which is -2x1 -2x2 plus 3 equal to 0. If an input happens to lie on or on the right side of this line, then you have an activation or an output of 0. If it happens to lie on the left side of the line, the output is equal to 1. It's a linear classifier. By simply changing the weights and the bias, you can change the position and orientation of this line, and therefore you can change the classifier. Now, let's take a look at the following problem. Let's say you have again your x1, x2 space, but now you have these red triangles in here, and you have the yellow dots right here. We'll treat these as two separate classes, and you want to essentially find points, determine when a point belongs to the class of red triangles. So now you have a region, and you want to build a linear classifier or a set of linear classifiers put together that can somehow define this region around the red triangles. So let's take a look at how we can do that. In other words, it's a more complex linear classifier. So here is a perceptron network, which we're going to use to do this. Again, the inputs are x1 and x2. And let's look at this perceptron right here. We know that we can build a linear classifier using that one. And let's say that that one has weights and bias such that it creates this linear classifier. And the output is going to be a 1 if you happen to lie beneath this line that you see right here. And now let's take a look at this one right here, this perceptron. Let's say that is this linear classifier, where the output is a 1 if you happen to lie to the right of this line. And then the third perceptron right here could be this linear classifier, where the output is a 1 if you lie beneath the line. And then the fourth one is this one, where the output is a 1 if you're to the left of the line. So now, you're going to get a 1 for each one of these perceptrons only when you have a point that lies within this region that you see right here. So now, if all of the perceptrons produce a 1, you can then create an output perceptron right here, which then produces an output of 1 only in the case when all the inputs are 1. And that's using these weights and this bias, for instance. You can use other weights and biases to do the same. So that's how you can create a linear classifier for a more complex region. I'm showing this in two-dimensional space, but this could be in any number of dimensions. That's what, in principle, what a perceptron network does for you. So we can construct a perceptron network, and in fact, it can be fairly complex. It can have multiple layers associated with it. So here is the terminology that goes with one of these multi-layered perceptron networks. The first layer is referred to as the input layer. So these are not really neurons per se. We're going to pretend they're neurons, but they're really the inputs that are being applied right here. That's the first layer. We'll call that the input layer, layer 1. And then in this particular network that I'm showing you, you have two hidden layers. These are perceptrons right here in the first hidden layer, which is layer 2. And this particular network happens to be a fully connected network, which means that each one of these perceptrons is connected to all the inputs. It doesn't really have to be the case, but that's just the example that I'm showing right here, fully connected. And then the outputs of these perceptrons serve as inputs to the perceptrons in layer number 3. And the outputs of those perceptrons in this particular case, go into a single perceptron, and that produces a single output. Doesn't have to be the case. You can have multiple outputs right here. That is, multiple perceptrons providing multiple outputs. It all depends on the application at hand.